let's move on. When you have the graph of the function and you need to determine the limit, it was pretty easy. Now let's have a look at the second example, where we have the piecewise defined function f of x defined as follows: x squared plus 5 when x is less than 1, it's equal to minus 1 when x equals to 1, and also it has the expression 2x plus 3 when x is greater than 1. So now we have the function defined in an algebraic way. The first question we need to answer is determine the limit of f of x when x approaches 1 from the left. Well, what does it mean when x approaches 1 from the left? It means that x is less than 1. So I'm going to look on the definition of the function on the first branch when x less than 1. So that's the expression that I'm going to take, because now I have three expressions for this function. It's not just the same expression every time. So that's basically the thing that you have to pay attention to. Selecting the right expression each time you try to calculate the limit. And in particular, for a function like this, you're going to have to approach the limit on its components, left and right hand limits, because you won't be able to find the limit unless you calculate the left hand limit and the right hand limit separately. So let's see what exactly we find. So I'm going to continue here saying that this equals to limit when x approaches 1 from the left from the expression is x squared plus 5. I can very easily replace the variable x with the value it's approaching, so 1, and I'm going to have 1 at power 2 plus 5, which is 6. Now the next point, it's asking us to determine the limit of f of x when x approaches 1 from the right. In other words, when x is greater than 1. So if that's determined, that x is greater than 1 from the definition of the function, the expression is here, 2x plus 3. So I'm going to continue to say this is equal to limit when x approaches 1 from the right from 2x plus 3. This is the expression we choose for f of x this time. And by replacing the variable x with 1, I'm going to end up with 2 times 1 plus 3, which is equal to 5. Now, at point C, what we need to determine is the limit of f of x when x approaches 1. Well, that doesn't mean that I'm going to go around looking in the definition of the function and say, okay, x equals 1, then f of x is minus 1, so this limit is going to be minus 1. No, that's wrong. You don't approach it like that. What you do is you rely on a definition that says that the limit of a function exists if the left hand limit and the right hand limit of that function exist and they are equal. And as we notice in this situation at point A and B, that's exactly what we calculated, the left hand limit and the right hand limit for this function, and they exist, but they are not equal. So by definition, our limit of f of x when x approaches 1 does not exist. So I'm gonna write here also the motivation, because the left hand limit is different than the right hand limit. And a couple more things that we need to determine for this function. So f of 1, well, now I'm gonna look in the definition of the function. When x is 1, f of x is minus 1, so f of 1 equals to minus 1. That is correct. And why do you need this sort of information? Because you may encounter an additional question, such as the one at the next point E. What type of discontinuity do we have when x is 1? This question goes even further, not only asking you if the function is continuous or not when x is 1, but what type of discontinuity does it represent? And as we noticed earlier, the left hand limit and the right hand limit, they exist, they are distinct values, so there is a gap between them, obviously, between 5 and 6. Plus, we see that the function in that point 1 actually gets a value of minus 1, so we right away can conclude that the discontinuity for this function when x is 1 is going to be a jump discontinuity. And now I'm going to make a sketch for you just to make sure you understand exactly what's going on with this function. But this is not required by the problem, and you probably shouldn't do it if it's not requested specifically. The graph of our function is going to look something like that. The first branch, when it's less than 1, it's a parabola because it's a quadratic function, and then when x is 1, the function gets a value of -1, this field point below the x-axis, and then when the values of x exceed 1, we have a linear function 2x plus 3, right? So you see we have this jump from 6 to 5. If we didn't have the middle branch for this function, or in other words, we wouldn't have any value for f of 1, then it would have been a removable discontinuity, but we have that value as well. So the function has a value for any value of x, but it has this jump. So therefore, the discontinuity is a jump discontinuity. So I'm hoping these examples are going to help you in your work. Thanks for watching.